All right, ladies and gentlemen, we're actually on to our last new content for this unit, and it's finally to the point where we have word problems. So the whole point of learning all this trig stuff is so you can actually solve, like a real-ish life problem using trigonometry. And here's some general steps that I recommend you write down or at least memorize to solve any of these. First things first is draw yourself a picture of kind of what that looks like, because that'll help you visualize what things you do know and what things you don't, so it can help you then solve your problem. You're then going to write out a trig equation using two things you know and then one thing you don't. So one unknown and two knowns. And then that sets up an equation which you can then solve. And then you should at least check to see if it's reasonable, and that'll kind of help you do some error checking along the way. So we're actually just going to do a couple of these. One of these is, for some reason, a lot harder than another, which is actually number 3. I'm okay if you try 3, but if you're not quite getting it, do the other ones first and then come back. It is an example of what a level 4 would look like, which is a more complicated situation. But let's dive right in. And just so you know, on all these, we're rounding to the nearest hundredth, which happens to be the second decimal place. We've been doing a lot of just first decimal places, but I want to add a little bit extra more precision to it, so we'll go to the second decimal place. On this first one, it tells you the angle of depression from the top of the lighthouse 150 feet above the surface of the water of the boat is 13 degrees. Sheesh. How far is the boat from the base of the cliff? So I'm going to actually redraw this triangle a little bit, because I want to imagine the triangle looks like that. It's more like we're trying to find this distance here. So you can see my wonderful lighthouse. It is perfectly to scale, and there is no better art out there. And then we got this boat, which is a very accurate representation of boatness. And you need to find this length here. So let's go ahead and label that at x. That's our unknown. Well, in our first sentence, it mentions this thing called an angle of depression. And this is not the clinical depression. This is depression like you push down on something, and that's called a depression. Like if you punch your pillow, you make a depression in it. That's what this depression is. And the angle from the top of the lighthouse, 150 feet above the water, to the boat is 13 degrees. So, 13 degrees. I don't know why my picture has a 15 in it. That's ridiculous. Anyway, it's 13. So the idea is when you're setting up a picture here, an angle of depression means you start by looking horizontally, and then you go down those degrees. So this is just normal line of sight straight out, and then this is the depression down. So that degrees there is the 13 degrees. Well, you may have noticed that this is not inside our triangle. Well, luckily, and you saw this when we started out, this still makes a triangle, but it's just not along the base. Luckily, this length here and this length are going to be the same. And so that's why at the beginning my triangle was up here. It's because I knew that I was going to use that triangle, and I can get this length will be the same as this length. It makes a lovely rectangle. So this is going to be my new triangle up here, and this length is still x. And now my angle is inside my triangle. You'll want your angle inside the triangle, whichever one you're drawing, so you can get your missing length. So I need to get this top one. And I don't know this one, and I don't currently have this labeled, but luckily, in the problem itself, it tells me that the lighthouse is 150 feet above the surface of the water. So if the boat's at the surface of the water, this length here is going to be 150, not degrees, feet. Feet are important units. And if I go back to the triangle I'm trying to work with, which is this one, this length is going to be 150 feet. So I'm going to use 150, not degrees. Stop doing degrees. Feet. So that one's 150 feet. And so if I look at my triangle here, I've got an opposite length from the angle I know. I have an angle I know, and then this side here, which is adjacent to the angle that I know. And so I have opposite, I have adjacent, and the trig function that uses those is either tangent or cotangent. I like using tangent because all the calculators have tangent, and cotangent is only on some of them. So I gotta do tangent of my angle, 13 degrees, and that's going to equal my opposite length, which is 150, over my adjacent length, which is x. So it equals 150 over adjacent, which is x. So now that I have my equation set up, I can solve it fairly quickly. If you remember on our last two or so lessons, you can switch those positions, and that's because normally to solve for x, you'd times by x, and then you'd want to divide both sides by tangent, which essentially just switches those places. So we're going to switch places here, and now we got x is 150 over tangent of 13 degrees, and this has two known numbers. These are actual quantities, and you can put them in a calculator to get your value. And just like it says, we're going to round to the nearest hundredth, so we're going to round to the second decimal place here. So I can go over, that's not my calculator. This is a calculator. And so I'm going to do 13 divided by tangent of, no, sorry, it's not 13. What am I doing? 150 divided by tangent of 13. I just have to, put things in there correctly. So I see I got 649.721. That's going to round to just 0.72. So I keep going to the wrong thing over and over and over again. 649 point, and I already forgot it. It's 72. So I got 0.72. And this was in feet, so I'm going to leave it as feet. So we got an answer. We should at least check to see if it is reasonable. So I want you to imagine you're atop of a very tall, 150 feet up in the air, and you look out and you look down 13 degrees. Remember, if you look just straight down, that's 90 degrees. 13 is about, 1/9 of that, 1/8 or so of that. So you're looking down about 1/8 of the way, which is not very far, and you look out and you see the boat. Well, that kind of gives a sense that the boat's pretty far away from where you're looking. And so, yeah, this is pretty reasonable to be about 650 feet because you're not looking down that far, which will mean it's pretty far out there. It's about 4 times as away as you are tall in the air. So that's pretty reasonable. We're going to do one more example for you. And I want to see if you can set it up. So we got a person 75 feet from the base of a barn. Let's draw a beautiful, beautiful barn. I'm pretty sure it has like moo cows in it. Moo cow. Yeah, just a box. That's what moo cow bodies are like, right? It's got ears. And we'll do a little spot there. All right, moo cow. There, we got a barn. And a person is 75 feet away. And we got person. Yay, person. Glorious, glorious person. And the angle of elevation from the level ground to the top of the barn is 60. So much like how the angle of depression is how far down you look, the angle of elevation is how far up you look. So if you're looking horizontally here and you go up 60 degrees, you'll find the top of the barn. So this is actually 60 degrees, and that sets it up quite nicely. And I should actually angle this so it hits the barn nicely. Whatever, it hits the top of the barn. Well, there's our setup. And you need to figure out how tall this barn is. So we got a lovely right angle. We need to find out this x. I want you to set up the equation and see if you can solve for x. Pause the video and go ahead and try it out. let's go ahead and see how you did. I noticed that my angle is here. I have the opposite side, and I have the adjacent side. So this is actually another tangent setup. Tangent of 60 degrees is equal to x opposite over adjacent, which is 75. I keep doing degrees, man. This is 75 feet. Feet. All right. And to solve this one, you don't want to switch these. You actually want them on the same side. So we're going to times both sides by 75. And I got x is 75 times tangent of 60 degrees. So I'm going to hop over to my calculator and put that in. 75 times tangent of 60 degrees. Push enter. And I got 129.903. That rounds to 129.90. So I got x is about 129.90. And this is all in feet, except for the degrees there. So I got my 129.90 feet. And let's imagine this real quick. This is actually probably a pretty poor drawing because 60 degrees is 2/3 the way up from horizontal. So really it should be something like this. So yeah, my drawing wasn't actually to scale there. Shocker, I know. That's going to be pretty common on my drawing. Sorry about that. So yeah, you look up 2/3 of the way. So you're not looking exactly vertical, but you're looking a pretty good way up. If your distance from the base is 75, it's kind of normal for it to be about twice as tall as you are away from the barn. So that is reasonable. If we got something like 3, there's no way that this barn is only 3 feet tall. So, you can kind of double check and make sure things are going pretty well done. So there you go, a couple of examples. Each of these problems are a little bit different, and they have varying complexity. But remember, angle of elevation is starting at horizontal and going up some degrees. So this would be 71 here. And an angle of depression, such as this next one, is starting at horizontal and going down. So if I was setting up my triangle like this, this would be 5 degrees there. So you just have to memorize the difference between the two, set up your right triangle, fill in the numbers you know, and then set up an equation and solve it. So there you go. Good luck. May the force be with you.